In this video, I'm going to be doing two problems, one easy and one a bit more difficult, where we're given position as a function of time and we're asked to solve for the equation for acceleration. And so let's start with the easy one. So we know, given position, to find acceleration, we have to take the second derivative. So the second derivative of the position function will give us acceleration. So let's go ahead and do that. To find the second derivative, we first need to find the first derivative. So let's start with that. The derivative of this function can be found just by using the regular power rule. So let's do that. 4at cubed plus 3bt squared minus 2ct, and that's it. Because d is a constant, so we're just left with this. So that's the first derivative, which is just the velocity. And so we know that the derivative of velocity is just the second derivative of position, which is acceleration. So the derivative of this is 12 at squared plus 6bt minus 2c. And that is our final answer. That is our equation for acceleration. And I'm gonna draw an arrow there so we don't confuse acceleration A with our constant A. So this A, B, C, and D are just numbers. Okay, so that's how we solve the easy problem. Now, let's do a more difficult one. So it's the same question, we just have a different function. So here we have that position as a function of time is x equals some constant A, which is just a number, times e to the power of t cubed minus t squared plus 4. So this whole thing is in the exponent. So same thing, we need to find the second derivative of this. And we start by finding the first derivative. So what is the first derivative? Notice we can't just apply our power rule here. We have to have another way to solve this derivative. And that's what makes this problem more complicated. So to do this, we first have to use something called the chain rule. And I encourage you, before I solve this problem, to try doing it yourself. But I will go through step by step here. So the chain rule basically says, if you have a function f, and inside of that function, you have another function, which is respect to time, and you're taking the derivative of that. So it could be any derivative. I'm just using t because we're finding a derivative with respect to t. But if you have a function with another function inside of it, how you find the derivative of that is you take the derivative of the outside function and leave, that's a t, leave the inside function alone. So you take the derivative of the outside function, forget the inside function exists, and just take that derivative. Then you multiply the derivative of the inside function. And so that is what we call the chain rule. So how do we apply that to this? Well, notice we have an exponential function with a polynomial on the inside. So an exponential function looks like something like this, e to the t. But so that's one function. But we have inside that this polynomial, so g is equal to t to the 3 minus t squared plus 4. So our x function is just a e to the g t. And so we can take the derivative of just our basic exponential function, which, what is the derivative of an exponential function? Like just a basic exponential function with positive exponent. The answer is it's the same. It's equal to its own derivative. And that's a property of exponentials. Then, so like this term, let's just look at this. The derivative of the outside function is just the same, so that is there's no change. And then we leave the inside function the same. So far, our derivative is the same. But now we have to multiply the derivative of the inside function, which is just the derivative of this. So dg dt. And that we can just use our power rule because it's just a basic polynomial. So that's 3t squared minus 2t. And then all we have to do is multiply that onto this. And so that is our first derivative. And this would describe our velocity. Okay, so that's one step down. Now we need to find the second derivative. So how do we do this? Well, we're going to have to use another rule because we have a function with respect to t. We can call this ft. And then it's multiplied by another function with respect to t. So if you have two functions multiplied with each other, to take the derivative, we use what is called the product rule. And this rule looks like this. So if you have ft times gt, you're taking the derivative. What you do is you can just write ft multiplied by the derivative of gt plus, now the one you didn't take the derivative of, or sorry, the one you did take the derivative of in the first term, you write just write the regular value, gt, and then you take the derivative of the one that you left alone in the first term. And this is your product rule. So when you're multiplying two functions and taking the derivative, this is the rule you apply. Okay, so in the case of this function, I already wrote it. We'll have ft here and gt here. And then we just need to find the derivatives of those two and then put them all together. So the derivative of, let's start with the derivative of f with respect to t. We would apply our chain rule again, right? Notice that this ft is exactly the same as the derivative that we did before. So I'm just going to write it out. It's the same, but you would solve it. I'm going to make this more clear with brackets. But you would solve it using the chain rule. Then, derivative of gt, just use your power rule. So that's 6t minus 2. And then we put it all together. So I'm going to write it down here further. ft, which is this, times the derivative of g with respect to t, which is this. So 6t minus 2 plus gt, which is this term, multiplied by derivative of ft, which is this. Okay, so that would be an okay final answer. It's correct. But we can simplify this down, and it's always good to simplify whenever it's possible. And so the first thing we can notice is we have two terms, and this a e to the t cubed minus t squared plus 4 appears in both. So we can pull that out to the front. And then we have big brackets, 6t minus 2, whatever's left over in the terms. So that's left over in this term. And then we have this multiplied by this, which are the same thing. So we can just write that squared. And then I'm going to just expand this out. So multiply them into each other, which would give you 9p to the power of 4 minus 12t to the 3 plus 4t squared. Then you can put that in for this, and that will give us our final answer. So that's a t to the 3 minus t squared plus 4. And it's good. It's nice to write it in order of descending powers. So 9t to the 4 minus 12t cubed plus 4t squared plus 6t minus 2. And that is your acceleration. So if you knew the constant a and you knew what time you wanted um, to solve for your acceleration, then you could plug those into this equation and you would be able to find that based off how the position changed with time according to this function. And so those are how you solve these problems. Just one side note to this. We didn't care about units in this equation or in this problem. We only cared about finding the equations. Um, with units in this case, it can be complicated. This is an exponential, so you don't have units inside the exponent. So this would be dimensionless unit of time, and then your units would come from whatever your a constant is. But I didn't want to get into that, and it's not as important as solving for your derivatives. That's the big point, is finding the second derivatives and the importance of knowing your derivative rules. Because if you don't know those and you can't solve derivatives, then it's not just hard, it's impossible to solve these problems. But that's how you do these problems. Thank you for watching.